substitute two conditions. At z equals 5, xa equals xa5. And at z equals 7, xa equals 0. You may wonder why xa is equal to 0. This is because the air flowing above carries the chloropycrin away immediately, so the concentration of chloropycrin at the top will be equal to 0. Now substituting the previous conditions, we get these two equations. Let's name them equation 7 and equation 8. I'm sure all of you know the equation of continuity. Considering that, at z equals 5, the following will be applicable. Now considering this, along with equations 3 and 6 as shown, we get a1 equals b1. Furthermore, considering this and equation 8, we get that b2 equals minus 7a1. Considering this, the previous equation and equation number 7, we get minus 2a1 is equal to xa5. It is done as shown. Now, due to concentration continuity, we know that the concentration at 5 cm of conical and at the cylindrical part is the same. Now, according to equation 5, 2.5a1 plus a2 equals xa5. Now we know that xa5 is equal to minus 2a1 as we derived before, and that ultimately leads to the following equation. Combining this and equation number 4, we get two different equations which we have to solve. Using the calculator solver function, we can use this to find a1 and a2. Now we have found a1 and a2, and subsequently we can find b1 and b2 as well using the relation a1 equals b1 and b2 equals minus 7a1. Now for the conical section, we need to find the concentration profile using the following equation. We substitute a1 and a2 and find the concentration profile to be the following equation. Now we need to find the flux profile of the conical part. We know that C equals P by RT, and pressure is given to us, we know R, and temperature is given to us as well. Using that, we find the concentration to be 4.09 into 10 raised to minus 5. Diffusivity is given in the question to be 0.09 centimeters square per second. Therefore, substituting all the values in the equation of flux, we can obtain the flux profile. It is to be noted that the flux profile and the concentration profile for the conical part will only be in the range of 0 to 5 for Z. Now to find concentration profile for the cylindrical part, we substitute B1 and B2 in the following equation to obtain the concentration profile, which is as follows. Note that this is from the range of 5 to 7 for Z. Now we need to find the flux profile for the cylindrical part. Substituting C, dAB and dXA by dZ, which is B1, we get a constant flux. That is 3.11 into 10 raised to minus 8. Now we need to find the evaporation rate. To find the flux at the top of the conical flask, we need to consider Z is equal to 7 cm. We know that flux is 3.11 into 10 raised to minus 8 for the cylindrical part. Now to find the rate, we have to multiply flux into area. We are considering the area to be 1 centimeter. And to convert it into gram per hour, first we multiply by molar mass to convert it to grams, and then we multiply into 3600 to convert it to per hour basis. We find the evaporation rate to be 0.057 gram per hour. We have come to the end of this question. Thank you.